Hi guys. You'll notice that this lesson has nothing to do with what we are currently learning, and that's okay. As a school, every grade level was supposed to pick a standard that didn't go as well as the others, mostly taken from your STAR 360 data, and for 8th grade, that would be the Pythagorean theorem. And so we're going to just do an extra little mini lesson on it through this video, and you'll take an extra quick check on it at the end of this lesson. Okay, so you'll have your normal lesson stuff that has to do with your current unit, but then also this on top of it. But I promise this is the only time it'll happen this semester. Okay, so the one that we chose for 8th grade is the Pythagorean theorem. So as a review, first off, the Pythagorean theorem is a squared plus b squared equals c. Oh, this should say equals c squared, not plus. Look at that, I'm already messing up. Okay, and it refers to the side lengths of right triangles. Okay, so this right here that I have drawn, this is a right triangle. Okay, according to the theorem, these are the legs. That would be like this side and this side. Okay, and then those are the legs. So if you square them and add them together, that should be equal to the square of the hypotenuse, which is the side that is opposite the right angle. All right, that's always the hypotenuse. So let's label that as well. Okay, now this information right here covers a couple questions on your quick check, so make sure that you have that written down. Pause this video, write it in your notebook, all that good stuff. That way you can get them correct on the quick check. All right, let's go into some examples where we actually use the Pythagorean theorem though. So with this first one, we are given the side lengths of the legs of 6 and 8 centimeters, and we want to know what is the length of the hypotenuse. So with that, we're going to use that formula, a squared plus b squared equals c squared. And then we're just going to plug in. Remember, these were the legs. This would be like our a and our b. So in this case, that would be 6 squared plus 8 squared equals c squared. Well, remember, when you square a number, that's like multiplying it by itself. So 6 squared is the same thing as 6 times 6, which is 36. Plus, and then 8 squared, which is like 8 times 8, which is 64. And that gives us c squared. Next, we'll add them together. 36 plus 64 gives us 100. So 100 is equal to c squared. So we're getting very close to c being isolated and figuring out what it's equal to, but it's still being squared right now. So if you remember back from our lessons on this, we talked about this as being like unsquaring the number, right? So if I unsquare both sides, or also known, the proper word for it would be square rooting a number. Sorry, I was opening my calculator and trying to get it cleared for you. So you're going to want to make sure that you open up your calculator, whether you're using one on a phone, you can use the Google one. You could also use Desmos, which is a website, right? It doesn't really matter. But what we'd want to do is we want to say 100, and then we're going to take the square root of that. That's that button there. And hit equals, and that's 10. So the square root of a 100 is 10, because when you square 10 times 10, it equals 100, okay? So the length of C would be 10. We were talking about centimeters, so we'll add that in there as well. And that would be your final answer. For our second example, this time I was given one of the legs, right, as 12. So it looks like A is equal to 12. We don't know B, and then C is equal to 13. Right? Now I know that partially based on which variables there are, but also remember the hypotenuse, or C, is the side that's across from the right angle. Okay, so that's how I knew that that one was C. And then I can just fill in that same formula. We've got a squared plus b squared equals c squared. Well, a is 12, so we'd have 12 squared plus b squared equals 13 squared. Okay? 12 squared is like 12 times 12, or 144, plus b squared, equals 13 squared. And I'm going to look it up just so I make sure that I'm correct. 13 times 13 is 169. Okay? After that, again, my goal is to get my variable by itself. In this case, I'm trying to figure out what b is equal to. So in this case, I'm going to work opposite or backwards from the order of operations. I'm going to subtract 144 from both sides. They'll cancel over here, right? Because 144 minus 144 is 0. We're left with b squared equals, and then let's see here, 169 minus 144, I think is 25, right? 9 minus 4 is 5. 6 minus 4 is 2. 1 minus 1 is 0. So b squared equals 25. So the last thing that I need to do is I need to unsquare it, or square root it. Which you can do this on your calculator if you need to, but the square root cancels the square. So we're left with b on the left. And then 25, the square root of 25, I know is 5, because 5 times 5 gets me back to 25. So the length of b would be 5. Okay? So, our last one, this one was a little more complicated, and this one definitely stumped people when we were talking about this in our lessons and the test and things like that. Our final goal, I didn't write it on here, but our final goal is to figure out what is d equal to, which that's called the interior diagonal, okay, of this rectangular prism. So, but I don't know enough information about it, or like about the triangle that it's attached to, in order for me to actually find it yet, okay? Because you'll notice the right triangle that it's attached to, well, I've got this height, I've got this length here, and I have that one. There's my triangle. So I'm looking for D. I do not know that measure. I do know the height because of this side here, right? This side is 6, which also means this side is 6. But I don't know this diagonal. So that's what I need to find first. I need to figure out what is that diagonal. Let me grab a new pen. My other one is kind of dying. Okay, so in order to find this diagonal, though, I can use the width of the box and the length of the box, because those can be the legs of my right triangle, and then I can find the hypotenuse, okay? So with that, I know, like, if this length over here is 7, that also means this length is 7, and then I know that this length is 12. So with my Pythagorean theorem, I would plug in 7 and 12 for A and B for this first triangle, the one that's laying on the bottom of the box. So we could say 6 squared plus 12 squared equals C squared, which, let's see, 6 squared is equal to 36, 12 squared is equal to 144. We'll add those together, and let's see, what do we get? We get 180, right? 180. So we'll have 180 equals C squared. The next thing we have to do, we have to unsquare both sides, because that will cancel out the square on the right and give us what C is equal to. Now, doing it on my calculator, I'm going to take the square root of 180. That gives me approximately 13.4. Okay? 13.4. So C, the length of this is about 13, sorry, and that's really tiny, 13.4. So now I know the measurements of the legs of that diagonal triangle that I need. right? So that the hypotenuse of my first triangle becomes one of the legs of the second triangle. So again, filling in the Pythagorean theorem, but now with this triangle's information, we would say 6 squared plus 13.4 squared equals d squared. Well, we know what 6 squared is, that's 36. And then let's see here, 13.4 times 13.4 is equal to 179.56 equals d squared. I'll add the 36 to it, and I get to 215 and 56 hundredths equals d squared. And again, the last thing that I need to do is I need to unsquare or square root both sides. On the right, I'll be left with d. That's exciting because that's my final goal. And then I'll square root the other side, which gives me about 14.7. And in this case, we were talking, all of these distances were in centimeters. And that would be your final answer. So you're going to have to use the Pythagorean theorem twice. Once with that bottom triangle and once with the diagonal. So I hope this helps. And if you have questions or need anything, as always, just let me know.